The Angel Legs Exoskeleton, developed by Angel Robotics in South Korea and launched in 2019, is clinically approved in Korea and Europe, with FDA review currently in progress. The device is a powered lower limb rehabilitation device designed to assist individuals with spinal cord injuries and stroke-related mobility impairments. The system provides active motion at the hip and knee joints, enabling controlled gait cycles under therapist supervision. The Angel Legs exoskeleton features a full-body support frame built around a central backpack module and modular lower limb assemblies. The shoulder strap secures the upper harness to the user's torso, while the waist strap stabilizes the main body segment and distributes load evenly across the pelvis. The thigh, calf, and foot supports connect the hip, knee, and ankle joints, holding each limb in proper alignment throughout the gait cycle. The guide button located near the shoulder allows therapists to trigger or pause walking sequences during rehabilitation. Beneath the upper housing, the battery cover protects the removable power pack, while the rear handle gives clinicians control over balance and movement direction during assisted training. A tablet PC mounted on the side acts as the primary control interface, enabling real-time adjustment of walking modes and parameters. The hip and knee joint actuators form the mechanical core of the device, converting electrical energy into joint motion that drives the walking pattern with consistent torque output. Together, these components form an integrated and adjustable system that supports safe, repeatable movement during clinical gait retraining. The structure is composed of multiple materials optimized for strength, comfort, and safety. The main frame uses aluminum alloy 6061 T6, selected for its high strength-to-weight ratio, fatigue resistance, and corrosion protection. With a stiffness value of 69 gigapascals and a yield strength near 270 megapascals, it provides structural rigidity while keeping overall mass low. The actuator housings are manufactured from ABS polycarbonate to prevent vibration transfer and mechanical damage. Stainless steel 304 is used at hinge and shaft locations to maintain long-term alignment under load. Thermoplastic polyurethane padding, known as TPU, is placed along all contact areas to distribute pressure and minimize shear stress on the user's skin. Together, these materials balance mechanical performance with ergonomic comfort. The comparison chart displays normalized performance scores for 6 lower limb exoskeletons: ReWalk 7.0, Indigo Therapy, Wandercraft Adelante, Honda Walking Assist, FreeWalk, and Angel Legs. The 4 parameters compared are total device weight, torque output, control response rate, and adaptability. Each metric is converted to a normalized scale between 10 and 100, where 10 represents the lowest measured performance and 100 represents the highest. This normalization process allows direct comparison between metrics that have different physical units, such as kilograms for weight and Newton meters for torque. Weight is normalized inversely, meaning that lighter systems receive higher normalized scores, while heavier designs score lower. Torque, response rate, and adaptability are scored directly based on performance output. In the chart, Angel Legs demonstrates high performance across all 4 parameters. It ranks first overall with the highest average normalized score, indicating strong balance between torque generation and control responsiveness. Wandercraft ranks second with high torque but reduced mobility due to its heavier frame. Indigo Therapy ranks third, performing well in weight but limited in torque capacity. FreeWalk follows closely behind with balanced mid-range values. ReWalk 7.0 ranks fifth due to higher mass and slower response rate, while Honda Walking Assist ranks sixth as it provides only hip assistance without powered knee control. The Angel Legs device achieves the highest overall consistency, combining low mass with high response and adaptability, resulting in superior rehabilitation efficiency. Thermal analysis evaluates how heat distributes through the system during continuous use. Infrared data shows that motor regions near the hip joints reach temperatures between 36 and 39 degrees Celsius after 1 hour of operation. The aluminum frame serves as a passive heat sink, allowing uniform dissipation and preventing localized overheating. The temperature difference between the actuator housings and the surrounding environment remains under 10 degrees Celsius, and user contact surfaces remain below 32 degrees. These values confirm safe and comfortable operation throughout long therapy sessions. Mechanical testing examines the relationship between torque and total stress in the aluminum frame. As torque increases from 20 to 40 Newton meters, equivalent combined stress, known as von Mises stress, rises linearly and reaches approximately 130 megapascals. This value remains below the 250 megapascals yield strength of aluminum 6261 T6, confirming that the frame operates within the elastic range. The von Mises stress represents the combined effects of normal stresses, which act perpendicular to the surface, and shear stresses, which act parallel to it. The results demonstrate that the frame can safely handle repeated loading without permanent deformation. Deflection analysis measures elastic displacement under load. When subjected to loads equal to 1 and 2 times the user's body weight, stress increases proportionally, while total deflection remains under 1.2 millimeters. This ensures the structure maintains rigidity during walking and returns to its original shape after each gait cycle. Assembly and disassembly are efficient and require no tools. Quick-release locking pins connect each limb module to the central frame, and the magnetic battery attaches directly to the spine plate. TPU straps adjust for even pressure and comfort. Disassembly involves powering down, removing the locking pins, and releasing the straps. The folded system measures approximately 60 by 30 by 20 centimeters for transport and storage. Maintenance procedures are simple and clinically oriented. All surfaces and foot sensors are cleaned after each session. Straps and connectors are checked weekly, while actuator calibration is performed monthly. The lithium-ion battery provides around 4 hours of operation per charge. Internal joints are sealed, eliminating the need for lubrication. Annual servicing includes firmware inspection and mechanical review to maintain reliability. The Angel Legs exoskeleton delivers the best measured balance of strength, adaptability, and control precision,